Hiya pirates! What we're going to look at today is the idea of stoichiometry, which is the next extension of everything that we have done up to this point. Up to this point, we have figured out how to go from grams to moles and moles to liters and liters to milliliters and atoms and molecules and all that kind of stuff in there. And we've been focusing with that on one particular substance. Now what we're going to do is we are going to take information about one substance and have it inform us about the amount of a different substance in a balanced equation. And stoichiometry is a weird word, but it makes sense if you understand the etymology of it. Stoichion is, I believe, Greek for element, and metron is for measure. So what we're doing here is we are measuring elements. We are figuring out how much of one is going to result in how much of another in a variety of different units. Let's start, before we get to the crazy chemistry aspects of things, let's start with a very simple example here. In its very simplest sense, one frame plus four tires is going to go together to make one car. All right. And so from this simple and basic idea here, we are going to be able to relate one to another. So for example, let's just say, for the sake of argument, that I'm an auto manufacturer and I have, how about 20 frames? How many tires am I going to need to go on those 20 frames? Well, that's pretty easy. I'm going to need 80 tires. That's just obvious, right? Or if I were to say, let's say that I had 20 tires, right? Then how many cars would I be able to make if I had 20 tires? Well, assuming I have enough frames, I would be able to make 5 cars, because there are 4 tires that go on each car. Now this is obvious, and ultimately that's really at the heart of what stoichiometry is here. It is comparing one thing to another thing. Now what we're going to be able to do is we're going to be able to take this stuff and we're going to be able to add it to our toolbox of equations, and we're going to be able to fit this into our mole map. But the simple basic idea of all of this is that if you have a balanced equation, then you can equate any two things that you care about in a particular problem. So if you want to equate frames and tires, then what you can say is you can say one frame is equal to 4 tires. And once you have that equality in your toolbox, you can then say that there is one frame per 4 tires, or if you'd prefer to flip the tile, you can go 4 tires per one frame, because they are both true, as we have talked about before. And so if these are the two things that you care about in your particular problem, then you can say this equation down here and have it be a valid equation. So if, however, you are interested in these two things in your equation, right? How many frames are you going to need to make a car? Well, then your equation is one frame is equal to one car, or there is one frame per one car, or there is one car per one frame. So if you have a balanced equation, what you can say is you can say any two things in your balanced equation equal each other. And again, our third example here is, let's say these are the two things that you care about, tires and cars. Well, then what you can say is you can say 4 tires equals 1 car, which means that there are either 4 tires per 1 car, or there is 1 car per 4 tires. So it all depends on what two substances you care about in the equation. And yes, every one of these, there are only going to be 2 substances that you care about. Even if there are 3, 4, 5, 27 different things in your balanced equation, you're only ever going to care about 2 of them. Which 2? Well, it depends on the question that is being asked, right? So for example, if I were to say, how many tires do you need for 30 cars, right? Then the two things that you care about are tires and cars. So that's here and here. So here and here. And so what you can say then is you can say 4 tires equals 1 car. And then you can go through and solve the problem. Now, I'll bet you most of you can just do this in your head, because if there's 30 cars, you know how many tires you're going to need. But when you get to the chemistry parts of things, it's not quite as easy and not quite as obvious. So what are we going to do? Well, we are always going to start with what we were given. So that's going to be 30 cars over 1. And then what we're going to do is we're going to scratch that out because we don't need it anymore. And now we want tires, and we have this new equation that we have here. 4 tires equals 1 car. So I'm going to go ahead and multiply this by 4 tires per 1 car so that my cars cancel, and I end up with 120 tires that are over here. So you can see all you're doing now is you are taking any two things in a balanced equation and you are setting them equal to each other. Now, this is important because you are going to use this tool in concert with all of the other tools that you have. So for example, what if I were to ask you, how many tires do you need how many pounds of tires do you need for 10,000 pounds of frames? How many pounds of tires do you need for 10,000 pounds of frames? So if we start here at 10,000 pounds of frames, are we going to need 40,000 pounds of tires because it's a 4-to-1 ratio? And the answer, of course, is no. That's silly. Why? Because tires and frames don't weigh the same amount. They are not the same weight. One frame is about 2,000 pounds and one tire is about 50 pounds. Now, I've just given you those. So if I know that one frame is equal to 2,000 pounds and one tire is equal to 50 pounds, and I know that I care about frames and tires, so I care about this and this, then I can add a third equation to that, which is that one frame is equal to 4 tires, and that's from my balanced equation here. Well, what about the cars? I don't care about the cars because they're not in this particular problem. So now what do I do? Well, now what I do is I start with 10,000 pounds of frames, because the question says I have 10,000 pounds of frames, and I want to know pounds of tires. So I'm going to start with 10,000 pounds of frames over 1, because that's what was given to me in the problem. And then I'm going to multiply that by one frame. It's going to go down here, and 2,000, whoopsie, see, look at that. Even we make mistakes. Pounds of frames, and if I were to do it that way, I'd be wrong because I have pounds and pounds. I put it the wrong way, but I noticed it as soon as I went to do it, so I just take this down here and I flip it like so. So I have 2,000 pounds of frames that cancel out my pounds of frames up here, and I have used that equation here. Now I'm going to multiply this by one frame down here and 4 tires up here so that my frames cancel, and I've used this equation. And now I'm going to multiply it by 1 tire down here and 50 pounds of tires up here so that my tires cancel. And now you'll notice everything is canceled here. Pounds of frames are canceled, frames are canceled, tires are canceled, and the only thing that I am left with is pounds of tires, which is what I'm being asked for here in the problem. And so at this point, you pick up your calculator and you do the math on these things. And once you do the math on this, you discover that this is, well, it's going to be probably 1,000. Let's see, here's a calculator. It's it's going to be 10,000 divided by 2,000 times 4 times 50 is 1,000. Yes, I thought it was 1,000. So that is going to be equal to your final answer here, which is going to be 1,000 pounds of tires. So you only need 1,000 pounds of tires to go with 10,000 pounds of frames, even though you need 4 times as many tires as frames, because tires weigh so much less than frames. So what we have just done here is what we have said is we're going to do this, we're going to have a brand new branch to our mole map, which is that if we want to go from one substance to another substance, it's the idea of moles that tells us how much of the substance there is in the number of pieces. And whatever balanced equation there is going to be, we can relate the two things that we care about in the equation by their number of balanced moles. So for example, if this is our problem, let's just say for the sake of argument that I cared about these two things. If that's the case, then I could write 2 moles of aluminum equals 3 moles of bromine, which means then when I go to do these problems, I could put 2 moles of aluminum over 3 moles of bromine, or I could put 3 moles of bromine over 2 moles of aluminum, if those were the two things that I care about. Because remember, in a problem, you only ever care about 2 things. Well, let's just say that that's not what I'm interested in. Let's say that instead what I'm interested in is these 2 things. What if I'm interested in aluminum and aluminum bromide? Well, if that's the case, then I would have 2 moles of aluminum equals 2 moles of aluminum bromide, which means that when I were to go to write out these ratio tiles, it would be 2 moles of aluminum over 2 moles of aluminum bromide, or I could do 2 moles of aluminum bromide over 2 moles of aluminum, if those were the 2 things that I cared about, which is why it's so important to have a balanced equation. If these were not the things that I was interested in, if instead I was interested in these 2 things, let's say it was bromine and the aluminum bromide that I cared about, those 2 guys are what I cared about, then it would be 3 moles of bromine equals 2 moles of aluminum bromide, which means that when I go to write the ratios, once again, I could put 3 moles of bromine over 2 moles of aluminum bromide, or I could put 2 moles of aluminum bromide over 3 moles of bromine, because they're both valid. Well, what about this guy? Well, who cares about that guy? We don't care about him in this problem if these were the 2 things that we care about. Well, how do I know what I care about? Well, it depends on the problem. So you have to read the problem and discover the 2 things that the problem is interested in you solving. So let's just say that this says, how many moles of bromine are needed to react with 4 moles of aluminum? So what do I want? I want moles of bromine and moles of aluminum. So I care about this and I care about this. So if those are the 2 things that I care about, then I'm going to write 2 moles of aluminum equals 3 moles of bromine. That is an equation that I will then get to write. Now, what does it tell me? It tells me that I am starting with 4 moles of aluminum. So this is 4 moles of aluminum over 1. And then I'm going to multiply that, and I can use this equation any way I want, 2 over 3 or 3 over 2, and it all depends on the particular problem. Now, please note that both of these guys say moles, but this guy is the moles of the aluminum that's here, whereas this guy is moles of bromine. So consequently, I need to put my purple 2 moles of aluminum down here and my orange 3 moles of bromine up here so that my moles of aluminum cancel. And now, what do I have left? The only thing I have left after he cancels with him is moles of bromine. What do I want? I want moles of bromine, so I'm done. So it would be 4 times 3 is 12, divided by 2 is 6. So my answer would be 6 moles of my Br2. So this guy here, this is starting to look very, very complicated, but ultimately it's not. What do they tell you? They are telling you that you care about silver and you care about aluminum. So here's aluminum and here's silver. These are the two things that you care about. The other things, if it makes you happy, literally scratch them off. Pretend they don't even exist. Because you don't need them. You only need them for a balanced equation. And I gave you the balanced equation. So what do you know? You know that 1 mole of aluminum equals 3 moles of silver because of your balanced equation that's here. And so what does it want? It wants to know how many moles of silver can be made from 0.75 moles of aluminum. So what did they give you? They gave you 0.75 moles of aluminum. And then we're going to multiply that. By the way, I've used that and I don't need to use it anymore. So now we're going to multiply that. Now do I do 1 over 3 or do I do 3 over 1? Well, what do I have here? I have moles of aluminum. So to cancel out that moles of aluminum, then that 1 mole of aluminum needs to go down here, and the 3 moles of silver need to go up here so that my moles of aluminum cancel. And so I end up with 0.75 times 3 is 2.25 moles of silver. So, one more example here. How many moles of NF3 can be made by 0.5 moles of F2 according to this equation? Well, that's an ugly looking equation. But if we're doing a stoichiometry question, then what we're going to do is we're going to care about two things. What two things do I care about? How many moles of NF3, so I care about him, can be made from 0.5 moles of F2, so I care about him. I don't even care about that guy. So what can I say? I can say 3 moles of F2 equals 2 moles of NF3 because of the 3 that's here and the 2 that's here. So now then, what was I given in the problem? Well, I was given 0.5 moles of F2, so I'm going to go ahead and start with that. 0.50 moles of F2 over 1, and I'm going to multiply that by either 3 over 2 or 2 over 3. Well, let's see. This is moles of F2, so that means my 3 moles of F2 have to go down here, and my 2 moles of NF3 have to go up here. So this is going to be 0.5 times 2 divided by 3, so that's going to be 0.333 moles of NF3. So now what we're going to do is we are going to take the traditional mole map, which is this single guy here, and we're going to double it into this guy here. Now you'll notice that everything over here on this side of the equation is identical to everything over here on this side of the equation. One side is an A side and one side is a B side. The A is one chemical, the B is a different chemical, and the only thing that I just taught you is everything I just taught you was here in the middle, which is that if you have a balanced equation, then the moles of A and the moles of B from your balanced equation are equal to each other. Everything else works just like it did in part 1 of this unit. So let's take a look at this. What does it say? It says, how many grams of silver can be made from 50 grams of copper? So what things do I care about in this problem? I care about silver and I care about copper. So I care about him and I care about him. Those are the two things that I care about. But if we look at our mole map, our two things here are going to be silver and they're going to be copper. So what do I care about them? Well, I care about the grams of silver. So if I go to my mole map, then I have my grams of silver. And I care about the grams of the copper. So I care about the grams of the copper over here. So what's it going to take for me to get from one side to the other side? Well, I've got to go from grams here to grams here. So it's going to take 1 step to get to here, 2 steps to get to here, and 3 steps to get to here. So I'm going to need 3 equations. And the rest of everything else in this mole map is completely and totally unimportant. I don't care about any of that. I don't care about any of that. None of the rest of this stuff matters down here because I'm going from grams to grams. So what are my 3 equations that I am going to have to write? Well, I need to know the periodic table for silver. So I get out my periodic table and I check out where silver is and I check out its mass. Here is silver, it's 107.9. So I go back then to this and I can write, just like I did before, 107.9 grams of silver equals a mole of silver. And that takes care of this step here. Now I need to use my balanced equation for this next step. So what 2 things do I care about? Well, apparently I don't care about him, and I don't care about him. I care about this orange thing and this red thing. And so if that's the case, then I'm going to write 1 mole of copper equals 2 moles of silver because of the balanced equation that is there. And then finally, that takes care of that step. I'm going to need to go over to grams over here. So again, I'm going to have to look at the periodic table, but this stuff over here is the copper. So I'm going to have to go back to my periodic table, and I'm going to have to find copper on my periodic table, which is right above silver, and it weighs 63.5. So I'm going to write 63.5 grams of copper equals 1 mole of copper. I now have everything I need to solve this problem because, according to my mole map, I'm starting here at grams and I'm going over here to grams. So that's 1 step, 2 step, 3 steps. Those are my 3 equations that are there. So what do? I always start with what I'm given. So that's 50 grams of copper over 1 because that was given to me in the problem here. I've now used that. I don't need to use it again. So now what do I need to do? I need to get rid of grams of copper. So where do I have that? Well, I have that in this equation here. So I'm going to put 63.5 grams of copper down here, and I'm going to put 1 mole of copper up here so that my grams of copper cancel. I have now used that. I don't need to use it again. Now I need to get rid of moles of copper. Well, that's this equation here. I'm going to put 1 mole of copper down here, and I'm going to put 2 moles of silver up here so that my moles of copper cancel. And that guy now goes away. Then I have 107.9 grams of silver equals 1 mole of silver. I'm going to put 1 mole of silver down here and 107.9 grams of silver up here so that my moles of silver cancel. At this point, I get out my calculator and I do the math on this. So that's 50 times 2 times 107.9 divided by 63.5. That looks to be about 169.9. 169.9 grams of silver, because that's the only unit that I have left. Check out this next one. How many milliliters of 1.25 molar HCl are needed to react with 10 grams of aluminum? So what 2 things do I care about? Because I have 4 things here, and this can get very, very confusing. Well, apparently the 2 things I care about are HCl and Al, which is this guy here and this guy here. So if you prefer, just go ahead and get rid of these guys and pretend that they're not even there, because you don't need them. I'm not asking you about those guys. They're only there to give you a balanced equation. Now, what is it that I asked you? If we go down to our mole map, one of these is HCl and one of these is aluminum. It does not matter which is which. But what did I give you? I want to know milliliters of the HCl. So the HCl, I want to know milliliters down here. And then this is grams of the aluminum. So I want to know grams of the aluminum up here. So my path on my mole map is going to be a 1, 2, 3, 4 equation system. And I'm not going to need any of the rest of this stuff because I am not asking you anything about any of this over here. And so consequently, all of that is just going to get in the way and be a distractor. So how then do I go about doing this problem? Well, I need to write down all of my equations. So first of all, I have 1,000 milliliters that equals a liter. Okay, I can write that down. 1,000 milliliters equals a liter. Then I need to know my molarity. So whatever my molarity is, that tells me my moles. So I look up here, and they told me my big M molarity was 1.25. So this is going to be 1.25 moles of HCl is going to equal a liter. I've used that now. Now I need to look at my balanced equation. And so I look at the numbers for the balanced equation. And those numbers are 6 and 2. So I can write 6 moles of HCl equals 2 moles of aluminum. And then finally, I want to go to my grams over here for my last equation, which means I need to look at the periodic table for aluminum because I'm now on the aluminum side of town. And aluminum is up here on the periodic table and it weighs 27. So I'm going to write 27 grams of aluminum equals 1 mole of aluminum. As soon as I have all 4 of my equations written for my mole map, then I start with what I'm given, which is 10 grams of aluminum, and I start knocking some of these things down. I got to get rid of the grams of aluminum, so I'm going to put 27 grams of aluminum down here and 1 mole of aluminum up here so that my grams cancel my grams, and then that cancels. And then I'm going to do 2 moles of aluminum down here and 6 moles of HCl up here so that that cancels. And then I'm going to do 1.25 moles of HCl down here and 1 liter up here so that the moles cancels the moles. And then I'm going to have 1,000 milliliters over a liter for this equation, and I am done. So at this point, you've got 10 times 6 times 1,000 divided by 27 divided by 2 divided by 1.25. And you get about 889 milliliters, which is the correct answer. So all you have to do to solve these particular problems is you have to look at the mole map, decide where on the mole map it is that you are going to go from, and use the correct equations in the ways that you have been taught.